Okay. That's good. All right. So everything looks good. All right. I think everything looks good. Right. How do I see if questions are asking questions? Okay, if it's like I can't really see like anything chat like any like what's it called? Any like chat questions and stuff like that. It's in my second screen. If anyone just has a question, just like speak it out and whatnot. So today I'm going to cover chapter 7, 8, and 9, I think. And yeah, let's get started. All right. So the meeting is being recorded, and yeah. So all right. So um, the question is this question is about electron configuration. It's basically the easier one of the easiest way we can do this question is by just counting the number of protons, right? For instance, like C has a number of protons, 20, right? Ca has number of protons of 20, right? So one way we can just like quickly do this problem is by just adding up the number, like these kind of numbers, right? And seeing which one is equal to 20. So if you were to do this, I'm just bringing out my calculator, right? And just do like 2 plus 2 plus 6 plus 3 plus 6 plus 3. This is equal to 22, right? So this is not, it can't be like one of the answer choice, right? And if you do the second question, 2 plus 2 plus 6 plus 2 plus 6 plus 2, this is equal to 20, right? But let's check the other answer choices as well. So we have 2 plus 2 plus 7 plus 2 plus 6 plus 2. But also consideration, like we have to take into consideration that there are some things that can be like valid. So for instance, S can only hold up to two, like F sub level can only hold up to 2 electrons, right? P sub level can only hold up to 6 electrons, right? So even if the electric configuration, like the electrons are like numbered correctly, let's say this was like S was only 1 and this was equal to 20, we can immediately say this is a wrong answer because P can't hold up to say can't hold it to 7 configuration, right? So we can just tell the answer is B. And the way I figured it out is by just like looking at a periodic table, right? And seeing where Ca was, like Ca was here, and this was 20 over here, right? Okay. So just by like doing the like configuration, right? How would we like approach this question? CR plus 3. Do you guys have any idea? Hello? Hello? Okay.
I'm here. Don't know the answer.
Okay. So all right. So okay. So when we do the electric configuration, right? There's a specific pattern we have to follow, right? So it goes from A so it goes from A to S. Okay. So it goes from 1s, then it goes to 2s squared p2. It just goes like this, right? So it just goes like that first, and that's like a pattern you kind of follow, right? But let's say you have like let's pick a higher one with a higher number. Let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So whenever you have Ca plus 3, does this mean you're subtracting the number of uh what is Ca or Cr? Okay, let's say we have Cr plus 3, right? What does like plus 3 indicate? Do you guys have any idea?
It loses 3 electrons.
Yeah, right. So we have Cr over here. So we have 24, right? The base ground is 24, but is losing the electrons. So you have to subtract this by 3. And this will be 21, right? But if you were to make like the sub-level, like the electron configuration, what would you say will come in it first? So this will be valid, right? So and the second, this will be valid, right? This will also be valid. But comes to mind, we have to go like from when you do like 2, 6, when you come here, right? We have to do 3s squared. And after that, you go to 3p6, right? But you don't go to 310, like 3d10. You go to 4s squared first. So it's like the pattern is kind of going like this. If I'm get what I'm trying to say,
Yeah, makes sense.
right? So what would be like correct configuration for this? For here we just count. So whatever the protons is 21, right? We're just gonna add that and see which one is the correct answer. 2 plus 5 plus 2 plus 6 plus 2 plus 2, which is 21. So I mean, this one is the first problem is the right answer, right? But let's try. Okay, but like you see, this P2P can also hold up to 6, right? But this one is 5. So this can't be the like a correct number of like configuration. We have to like check the other ones as well, right? So plus 6 plus 2 plus 6 plus 2 plus 1. So correct answer will be this because because all the sub like S can only hold to 2 electrons, right? P can hold to 6, right? And D can hold up 10. So this doesn't like break any rules over here, right? That's why the answer is that. So this is just like a quick note of what I just said, right? So how, what is it? Which one is the correct configuration for Ca? First, we have to look at where in the periodic table where the Ca is and find the numbers of electrons, right? And the Ca has 20. I think number of protons. My bad, not electrons. Now we have now we just need to look at like how many electrons are in each sublevel, right? So S can hold up to 2, P can hold up to 6, D can hold up to 10, and F can hold up to 14. And the pattern that I just showed you, like that's how you like goes down on, right? So this is just like a quick note if like what I was trying to say did not make sense, right? And whatnot. So if do you guys have any questions regarding this? Like these kind of problems?
No.
Okay. True. All right. All right. So I just want you guys to like do this problem with me, right? Obviously there's only like 2 students here, so I'm not gonna like force you guys to do anything. But this is saying Ti minus, right? So what is it configure? Let's figure out the number of protons that this thing has first, right? So T has 22, right? But it's like we have to take into account of the charge. So this is adding plus 1. It's like adding one more electron. So this would be 23. So quickly we can just like do which number of like which kind of these like subscript or superscript add up to 23 and just figure it out from there. Okay, this one is 23, but it's not valid because P6 can hold the sixth number of electrons, right? So we have to take into consideration of that as well. So 2 plus 6 plus 2 plus 7. This is not valid either because it can only hold up to 6. It can't go up to 7. So the answer would be C. Okay. Sorry, to interrupt, right? But did you guys understand what I was trying to do? Like how I got the answer C and whatnot?
Yeah, I got C too.
Okay, cool. All right. So next we're gonna look at which element has the largest number of atomic radius, right? So for this question, we just look at the like a trend. So atomic radius it increases from like this kind of pattern. So in periodic table is going to the left, and that's where it's increasing from, right? So if you want to visualize it a little bit, this is how the each atomic radius looks like. So like it's increasing from this side to that side, from left to right, and it's increasing from like up to down, right? This is all you guys need to know for the atomic radius. There isn't much to it, and you just like kind of look at the periodic table, seeing how the trends are, and try to figure out what the answer is. For instance, so let's do question number 3, right? So which element should have the largest atomic radius? Let's try to figure out where like each element is in the periodic table. So we have He over here, right? We have H is over here, right? Kr is over here. And Xe is over here somewhere. Um,
It's on group 8.
Group A. Okay, thank you. Where'd it go? Xe, yeah, it's in group A, my bad. Sorry. So here, right? But so atomic size is increasing from like up to down to like is going like this, and it's going from left to right. Yeah. So we can just tell the answer is Xe, right? Because this is the biggest number of atomic radius. Yeah. So let's do question number 4 together. So which element should have the largest atomic radius? So if you were to look at the periodic table again, right? So over here, I'm just gonna highlight like where each one is. So we have oxygen over here, we have Ne over here, neon. We have Ti. Where is it? Ti over here. And we have TiCa over here. So atomic radius means it's increasing from this side to that side, right? So that's how it's increasing. I'm not gonna write everything down, but um, atomic radius. So like just by looking at this, right? Where's Ti? Where did I highlight Ti from? There you go. What would be the answer? So the atomic radius is increasing like this from this side to that side, right? And is increasing
Yeah.
from up to down. No, it would be Ca. Or would yeah, because it's increasing like this. Makes sense. Oh, maybe I highlighted on this was Ci. My bad. I did this one. So it was like increasing like this. So the largest one here is Ca.
Makes sense.
Yeah, cool. All right, thank you. Ionization is the same thing as atomic radius, but instead it's kind of opposite. So we have atomic radius going like this, increasing like this, but ionization is increasing like this. So if you were to take a look at the periodic table, right? So it's going to be increasing like this. This is how ionic energy will be increasing, right? So this is the same thing that's what I just said, right? Let's do this practice problem, all right? So where's um K out? So this is going to be over here. K is going to be over here. CA is going to be over here. SI is going to be over here. Okay, where is SI? Can one of you guys help me find where SI is? Maybe I'm missing something. But
It's group 14. It's under carbon.
okay, there you go. So what is the largest ionization energy? It's a SI, right? Because this is one it's increasing from this, like increasing like this.
Yes, makes sense.
Yeah. So this is basically the same thing what I just said. I just wrote this down. And okay, so this question is kind of a little bit tricky, right? So it's saying like which one has the biggest ionic jump, right? When it says biggest, what it's like just saying which one is removing the co-electron after the valence electron is gone, right? So if we were to take a look at the periodic table, right, it's like this, and we have like 1, 2, and this is a transition metal, 3, 4 till 8, right? So 3, 4, 5, 6 till 8, right? So it's saying like which element has the biggest ionic jump. So you count the valence electron per se, right? So 1, 2, 3, 4, 5, 6, 7, whatever, right? But you subtract 1. So here it says like biggest ionic energy. So if I were to take a look at the periodic table, right? So I'll go from it's in seventh. It says seventh. The key word here is seventh, right? So 1, 2, 3, 4, 5, 6, 7, right? But you don't look at this chart at all. You look at the one below it. So you look at this. So whatever the answer, whatever the element that's in that like in this group is the answer. So for instance, the question was here, which one is the biggest ionic jump in seventh ionization energy? The answer, the element that you select for the answer is S because that's the only option here. If that makes sense. So you don't have to like necessarily calculate anything. You just have to know like, oh, if it says seventh, you just go up to 6 valence electron and select the element from there. Right?
So it's always one less.
It's always one less, yeah. So for instance, like if you were to do the question, if you were to do this question, right? Um, which one will have the biggest jump in fourth ionization energy? So you go from 1, 2, 3, 4, right? But you look at the group from this side, only this side. So the answer here will be, so there's no H here, so this can be removed. There's no B, I mean, there is a B here, so this is probably going to be the one of the answers. There's no oxygen here anywhere, right? And there's no BE, so answer is B, if that makes sense.
It does.
Okay, I want you to like do this problem by yourself then, like this one. Problem number 6. So this question is asking like which element will have a biggest jump in 6 ionization energy, right? 1, 2, 3, 4, 5, 6, right? But you go one less. So you look at the answer, like the answer has to be in one like group from here, one of the groups here. So what will be the answer? Nitrogen, right? I heard N.
Yeah.
Right? Okay, cool. Thank you. All right. Okay. So this is one of the like this is one of the questions from ACS question. I'm not sure it's gonna be beyond the exam or not, but I was just gonna cover like every single one of the questions anyways because it's kind of easy, right? So isosonic electron just means which like which are the two elements that has the same number of electrons, right? So if you were to look at like F minus, right? So what is the number of electrons that F minus has? So first you go to F, right? So 1, 2. Oh no. Oh, let's go. Where's F? So F is here, right? What does like a -1 means? You have to add an electron, right? So F is actually 10, right? Are you guys following me here? Hello?
Sorry, can you repeat yourself?
Yeah. So look, isotomic like isoelectron just means like we're just comparing two elements, right? That has the same number of electrons. So it's just basically asking which are the elements that has same numbers of electrons. That's pretty much it, right? So okay, tell me like how many numbers of electron does F minus 1 has, just by looking at the periodic table.
Does it have 7?
I'm sorry, 7.
7?
How did you get to 7? So F is over here, right? So base is 9, no?
Okay,
Right?
yeah, that makes sense.
So base is 9, right? So F, but remember like earlier you said when you have a like plus, you take away electrons. But what happens when you have a minus here,
You add 1.
right? So the answer will be 10, right? So F has like 10 electrons, right? But the question is asking like which one has the same number of electrons. So F minus 1 has 10 electrons, right? So we just have to like figure out like which one is the next element that has the same number of electron as F minus 1.
Is it Mg plus 2?
Yeah, because like this is 12 plus 2 means minus 10, right? Pretty simple stuff. So I don't know. Do you guys want to go over this question, these two as well, just quickly?
Yeah, sure.
So n minus 3, right? So how many numbers of electrons does n minus 3 has? So n is 7.
10?
Minus 3 is adding, right? So 7, 8, 9, 10, right? So we just have to compare which one has 10. Hello?
Trying to find the elements.
So element is here.
Makes sense.
Element is here, right? So Na plus 1. Plus 1 means you have to subtract the electron. So Na plus 1 plus will be like just 10 electrons, right? Cool, right? Does that make sense?
Yeah, it does.
Okay, can you like explain to me how would I get this answer then? Ne. It's like what is the like same isoelectronic ion for Ne?
So Ne has N, so you have to find one that would also have 10.
Yeah. So like it will be Mg plus 2, right? Because that's
Yeah.
S. Okay, cool. Okay. So this question is asking which one has the lowest electronegativity. It's basically the same as like ionic energy. It's just like going from bottom to top, right? So I didn't like try to explain it too much, but okay, just by looking at the chart, which one would have the lowest like electronegativity? What would be the answer? So we have Mg over here, right? We have S over here, right below F, and we have P over here, right next to S, and we have Al, aluminum. So which one have like a lowest electronegativity in this question answer?
Would it be Mg?
Yeah, right. I mean, this chapter is not really that hard. You just have to know like the electronic trends, ionic trends, and kind of a tricky question, right? So if you have any like questions in regard to like this chapter, like which is chapter 8, I believe, um, please let me know. Do you guys want me to like go over like any questions from like what I went through, or do you want me to like re-explain anything? Please let me know now.
I have a question.
Yeah, go
Did
ahead.
you just go over like the question that talked about like isoelectronic stuff?
Do you want me to go over it again?
I think I missed that, but no, like my question was because when I was doing the exam, I got a question that's like, which one is isoelectronic with chlorine with like uh the minus superscript, and like the options were like argon, aluminum, potassium, and calcium 2 plus. So like I don't know how to like decide like differentiate because a lot of them were similar.
Okay, so chlorine was which one is the chlorine?
Like yeah, chlorine with the minus sign,
Okay, chlorine with minus. So
and
this
then
is 18,
yeah,
right?
18, and then the options were argon, which is also has 18.
Wait, did you guys already start the exam? I thought the exam wasn't until this week, no?
No, I mean like when I was doing the practice exams.
Oh, okay, cool.
Yeah.
All right. Okay, so what was the option?
Argon,
So argon, right? So we
yeah,
have R,
aluminum, and potassium.
potassium, so 15. And what was the last option?
Oh wait, isn't potassium K?
Isn't potassium K?
Oh, my bad. I
Yeah.
haven't I'll be honest with you. I was working on this like app, so it took me all day. Um, okay, K was
Yeah. And then calcium like 2 plus. Wait, what's the correct way to say that? Sorry, like when you like
calcium plus 2. I think I have to say like calcium plus 2. I
okay.
mean, pretty much it. So this will be 20. So 20 minus, so 18. So yeah, it will be 18. Okay. All right. I think the answer will be the whichever the closest element nearby the chlorine. So the next like closest element to chlorine is 18. Where like isotonic electrons just means like which one is kind of like similar, right? So the next like similar answer is like AR. This question is kind of flawed because when we're comparing the protons, um, yeah, I get what you're trying to say, right? This was also 18 and this is also 18. I'll just go with whichever the closest to the periodic table. The answer is to the periodic table.
Okay.
So, I mean, whenever we do the base electron of configuration, right? We always go with the number of what's it called? The
No
number of
gas.
yeah, like noble gases, yeah. So when we do like a base configuration of that whatever, right? We just go like with the AR. But what? Hold on.
Yeah.
Yeah, we can. Yeah. Yeah, that's fine.
Okay. Yeah.
I think I do. Yeah.
I'm still getting used to using like the chart itself, but I get like the concept. Like, yeah. I'm good.
I'm good too. But it's gone now.
Let me go back. Yeah. I got it.
Okay, yeah. Would carbon be in the center and then it would have like 3 branching H's? Does it have something to do with electronegativity? So the one in the center has to have the most. Okay. Electronegativity? Yeah. Okay. Well, like first I'd like draw that and then afterwards I'd like go in and put the dots in just to like have like a starter. Yeah. Kind of. So they have to be connected because it's like in one. Uh, right. Okay. Okay. Yeah. So the carbons connect and not the hydrogen because hydrogen can only take on one valence electron. Yeah. Not really. Is that a double bond between the C's? Okay. Yeah.
Can you guys see my? Okay, can you guys see my like paper?
Yeah.
Okay. So you guys understood like where I got the product and reactant, right? So we are here so far. Can you guys see like what I'm writing and whatnot?
Can you move the camera? But yeah.
Hold on, let me see. Okay, cool. Right. So this is the reactant, right? And we have the product over here. So look, we have these two, right? Do you guys get it? Like how I get the Lewis structure and the bonded form from this problem?
Yeah.
Okay, cool. So now
Yeah.
we're looking at like how many bonds, how many like the formula for this question is like formula is bond broken minus bond form, right? So when we're comparing the reactant with product, right? We have to see which bond, which from what is like being broken from here to there to form the product, right? So can you guys tell me like, okay, from when you go to reactant to product, right? What are like the bonds that are being broken?
You mean like covalent or like hydrogen, like that?
Right. So like you see like to make the double bond here, right? You see the to make a double bond here. What was being broken here?
Is it a hydrogen bond?
No, no, no. It's being broken. Yeah, you're right. It is a hydrogen bond right, too, right? But it's carbon to carbon bond as well, right? So this has to be broken first to make the carbon double bond of C to C, right? Carbon to carbon, right?
Why is it broken if it's getting another bond?
Because we have to break this as well. It can't be like formed to make a double like a single bond, if that makes sense. But this has to be this has to like be broken first to join again, if that makes sense,
Oh,
right?
okay, okay. Okay, yeah.
So okay. So but here we have like another two bonds that's been broken to form this H2H, right? So what are the two bonds that's been broken in reactant to form the product of H to H, the single bond of H to H?
Would it also be covalent? Does the C's have to break, or would it be hydrogen?
It'll be hydrogen, right? Because we just need hydrogen to break. So we have to break free from this one, right? This one and this one, right?
So if you're breaking those, the carbons don't have to break. It's only if the carbons are like coming together.
But no, no, no. But this is also being broken, if that makes sense. We have to break it in order to make another like bond. So when you're thinking about like in terms of like valence electron, right? So to break a single bond, we have to break the single bond first. Then it joins. If that makes sense. If it's not the same, if it's not the same as the same like the reactant, that means it's being broken. I know what you're
It's
thinking, like,
happening
oh, you don't have to
at
break
the same
this.
time.
Yeah, yeah, yeah. So I know like it's kind of confusing when you like look at this. This is not really being broken, right? It's just being added on a bond. But in order to do that, we had to break this, if that makes sense. Then no, you can join it again.
Okay, yeah.
All right. So do you guys get this to part, like reactant and product, like what I did here?
Like how it got from there to there.
Yeah, no, this is just like the question. Like I'm just literally just making the Lewis structure for destruction.
Yeah. Yeah,
So,
yeah.
but like I'm analyzing like which bonds are being broken and which one is being formed. So here, right? From like here to there, what is being changed? You know what I mean? So these bonds are being broken, right? We have
Yeah.
the new addition of C to C, right? Double bond from here, and we have new addition to this one, right? Single bond of H to H, right?
Yeah.
So if I were to say bond broken, right? So first we have C to C, right?
Mhm.
I'm writing that down here. Then next we have C to CH, right?
Yeah.
I mean C to H, right? And the other
Yeah.
one we have C to H, right? You guys follow
Yeah.
me till here? So do you
Mm.
guys like follow me from making the Lewis structure from this part to and going how I like to analyze what was being broken?
Yeah, yeah.
All right, cool. So I'm gonna write about the bond being formed. So this question, right? So what are what are the bonds that's being formed here? Double bond of
Carbon to carbon
yeah.
and a hydrogen to hydrogen.
Hmm. So the question is asking like what is the like change of energy when it goes from like product to reactant, right? So when it goes from here, like all of this being to combine to being broken, right? What is the energy being taken? This is a formula, right? So broken bond minus bond formed, right? So what is the energy from C to C? If you were to look at your table, right? What is the energy from C to C?
346.
V.
No,
Look, so look, are you guys seeing the table here?
is it 602
6602. How'd you get 602 from C to C?
on the bottom part?
Bottom part? No, okay, no. Okay, yeah. This is right, but this is a double bond, right? But we're looking at the single bond here.
The 346?
346, yes. Okay. Right? And just by looking at the same table, right? Um, H to C, what is the answer? C to H.
411.
Mm-hmm.
So would you times that by 2 because it's happening twice?
Yeah, but I just like to add it. I don't know. It's the same thing.
Okay. Okay.
But okay, let's add all these, right? So we have 346 plus 411 plus 411, right? We have 1168, and we have double bond of a double bond of C carbons, right? So you said earlier, what was the answer for this one?
Uh, it is 602.
602. What about hydrogen to hydrogen?
432.
Okay, I'm gonna add these up. All right, so we have 1044. So we just subtract these two. Minus 1034. So the answer will be 134. To change in H. Okay. Does that help a little bit?
Yeah. Can you post like this page
I
too?
I posted the whole video on it. So if you were to okay,
Oh,
um,
okay, okay. I got it one.
it's the same question. I'm just going over it again. Okay, if you were to like take a look at it, it will make sense. So can you look at the chart and look at this YouTube video that I made?
Should I press on it?
Yeah, just press on it. So I'll just press on it. Um,
So hello guys, this is
I'm explaining the same thing here.
That's gonna be
Like, what is the same question? But at the end, I made like a little bit of error. I did, instead of saying minus, instead of saying addition, I said minus.
to use the table, so you guys will see.
So you see, like here, I just made an error,
like a table,
but this is addition.
right? And you guys have to figure out the change.
Okay, yeah, I see it.
So
Yeah. So this is just explaining the same question that I just did.
do this question.
Like, it's just literally the same thing.
You guys have to know perhaps a Lewis structure where
Okay.
to find
And I think I'll post
and whatnot.
like
But for now,
other videos as well,
for instance, so
relating to chemistry. But
if you were to,
it is what it is. That's for the later time.
I'm just making a little chart.
So this video, right? Like at the end, I made an error here saying like, oh, like 602 minus 432, but that was supposed to be addition. But I did add it. I just said subtract.
Okay.
Okay. All right. All right. So are you guys down to do another question that's similar to this one? Like this is the same. Like so this is the same one, but it's like just a different compound. Do you guys want to do this? We can do it real quick. It's gonna be easy.
Yeah, I think that would be helpful.
All right.
I have a question about the last one.
Yeah. What's up?
When we're talking about the signs for the final answer,
It's always adding. It's adding.
just adding. Okay.
Oh no. Signs. It's gonna be negative. Like it's gonna be the exact answers. But what I was trying to say was that I made a mistake in the video. Instead of saying subtract, I said add. I mean, instead of saying like add, instead of saying add, I said subtract. That's pretty much it. But the answer you will get in the calculator or like when you do this problem is exactly the same. It's just bonded like a bond broken minus the bond form. That's the formula.
No, yeah, I get that part. I meant like, so the final answer for this one was 134. Like, what's the difference between 134 and minus 134? Like, what does that mean? Like,
Minus 134 is wrong because it's doing like it's doing like product minus reactant instead of reactant minus product, if that makes sense. So when you're calculating, right, the formula is always like bond broken minus bond formed, if that makes sense. But when
yeah.
you do this, it's always going to be like it will always give you the right integer. Like it wouldn't never give you like a negative or positive. So if you put negative 134, it's going to be wrong. The answer is positive 134.
Okay. So will we always get a positive answer?
No. Like it depends on the question. Like when you maybe like if the like a bond broken is like less than bond form, then it's going to be negative.
Oh, okay.
It's not always going to be positive. So when you do like bond broken minus bond form, the whatever integer that you get, whatever the answer that you get is the right answer if you did it right.
Okay.
Yeah. Okay. It's not always going to be positive if that makes sense.
Yeah.
All right. So I mean I kind of did it here, but I'll walk you through how we did do this question. Actually, how about this? How about you guys tell me like how to make it, and we'll compare the product and reactant and see which one being broken and whatnot. All right. So it's kind of helpful. All right. I'm gonna put this question in a reference. Um, go ahead. All right. We have it's going to N2 plus 2H2. Right. So how would you make a Lewis structure for N2H4? Okay.
Would it be two ends bonded and then like two H's going off on either end?
Okay, how many bonds though?
I have to work that out first.
Okay, so tell me how many valence electron does that nitrogen have? Hello?
Yeah, it has 5.
So 1, right? 2, 3, 4, 5. Do you guys understand why I'm making it clockwise? That's just one of the rules. You just have to go clockwise like that, if that makes sense, right? So you don't like mess up the bonds. So we have the same thing here. Okay. Insert, draw. 1, 2, 3, 4, 5. Okay, just by looking at this, right? How many like bonds can we have here? If you're just connecting like and together. So this
In total?
yeah. So this lone pair can connect by itself, and this lone pair can connect by itself, right? But when you were to connect, like, let's say you want to connect end to end, right? How many bonds can we have here now? Like, how many? Like, is it going to be single bonds? Is it going to be like double bonds?
Double bond.
Okay, explain to me why.
Um, because we have two single bonds. Like the lone pair on top can create one, and then
Okay, so we can't have double bond, right? Right, listen, right? So we can have a single bond, or we can have a triple bond, right? So this can go to this one, right? But this can go to this one, right? And we can connect these one together, if that makes sense, right? But we're not going to do that because whenever these type of question, we always assume is going to be the higher number of bonds. So we can have 3 bonds, like so each lone pair can connect to each one, like this, like this, like this, and the same can go like this. Does that make sense? So if I were to rewrite it, if I were to redraw it, right, it would be like 1, 2, 3, and one lone pair here, one lone pair here, right? If I were to just draw N2,
yeah, got it.
you get it? Now we have to add 4 hydrogens, right? So how would we go about doing that? Maybe, wait, hold on. Is it actually 2? Yeah. Yeah. So we have 4 hydrogens here, right? So we still have 2 lone pairs here, right? So I can just connect H here, here. Right? Is everybody good here? Do you understand how I got this?
Yeah, I do have a question though.
What's up?
So if you put in an H on the top, would that be wrong?
No. So if you put, but like, oh, if you added one more H over here,
No. Like if if it was like H on the top and then H on the left, but like no H on the bottom.
so like, but you only have 2 H. In total, you
Yeah.
only have 4, right? Yeah, no, it doesn't
Yeah.
really matter. You can put it like
Okay.
here. You can put it like there. It does not really matter where you put it.
Okay.
So
Perfect.
this is the was this the reactant or product? Okay, it was a reactant, right? Right? Cool. So this is H. You guys have this, right?
Yeah.
Okay, I'm gonna create one more. Now I'm gonna make a valence electron. I mean, not valence electron. Sorry, Lewis structure for the product. So we have N2. plus 2H2. Okay. Just making a redundance and repetitiveness, right? How many bonds do we have for N2? How many bonds do we have for
Eight.
N2? 8? Wait, what?
Was it
3 bonds.
3 bonds, right? I heard 8, my bad. 1, 2, 3, right? And how many lone pairs do we have? Hello? Can anyone hear me?
These 2.
2 on what? Like for instance, 2 like this?
No, like 1 for each N.
Okay, cool. Okay, so do you guys understand like how to make the Lewis structure and how the bonds came here, right? At least up to that part, right?
Yeah.
Cool. Okay, so now we have 2 hydrogens. So, I mean, is this gonna have a single bond, right? For 2 of them.
Yeah.
Let me see. Yeah, it's gonna be like this. It doesn't really matter where you connect it, but all right. So when we look at the reactant and the product, right, we're just comparing like which one is we're just comparing like which one is changing from what, right? It's kind of hard to do. So if you were to duplicate, copy this maybe, can you slide, link it here? I can't even do that. All right. Okay. Okay. So just like you guys wrote it down in your paper, right? So just compare how many bond forms we have here. All right. I'm gonna write it down in my paper as well. So the reactant we have. So this will turn into N plus so bond broken, bond form. Okay, so let me pull out my phone again. All right, so we have like this, right? Can you guys see my paper?
Yeah.
Yeah.
So okay, tell me how many bonds were broken to form the hydrogen here. So did we do anything with Na, like N over here? From when it goes from here to there, right? N doesn't really change, right? So we don't really need to do anything there. So tell me how many bonds were broken from here to form this thing, basically.
Is it 4 H bonds?
So it's gonna be bond broken. So it's gonna be like from N to H, right? These bonds were broken, right? So damn, bond formed. Okay. Oh, had the solution written wrong. Okay. So these are the bond being formed, right? So if you were to look at the table, so we are going from so H2N, so it'll be 386, 386, 386, Wait, why does this write 2? This is being broken. Yeah, okay. I don't know. I had it wrong. Anyways. I'm gonna add all this. 1, 5, 4 minus. Okay. Let's look at the answer choice. No. Okay, I did something wrong. I know the answer is 95, but where did I go wrong here? Bond broken. Oh, yeah, no, never mind. Okay, so there's only been one being bond. Okay, I calculated it wrong. Wait, so we have, why do we only have 2 bond broken? So if you break this, and that will just be connected. 4. Oh, okay. All right. So, okay. So this one is being added to, okay, we have 2 more like hydrogen atoms here, right? So only thing we're like breaking here is, wait, that doesn't make sense. Why is it 95? Wait. Did I do the bonding wrongs? 1, 2, 3, 4, 5. So we have 4, 2. Maybe just connect 2. 1 bond electron. Okay, let me get back to you on this question. I'm not really sure like why we wouldn't count for like this one, if that makes sense. I know the answer is like 95, but I don't know why we're not considering these 2 bonds here. Okay, sorry about this. Let me get back to you on this question, all right?
Okay.
But yeah, I'll make a video about this question. But I'm pretty sure like is this 2 bonds that have been okay. So we have N2. This is lone pair. 2H. So it's B. So we only have 2 of them. So this is correct. N2H4. Okay, bonds being broken. But this is the same. We don't account for that. This and this is connected. This and this is connected. Okay, yeah. So we only need to break 1 bond to connect with that one. Okay. So we don't really have to like necessarily break. So we don't really have to break everything here. We just have to break one of these here. So look, so we can just break this one and connect this with that one. We can just break this one and connect this with that one. That's why it's forming like this H to H. Technically, right? So the adding here will be,
Aren't those still attached to the nitrogens?
it is, but I think we can still do like the H to H because it's not like necessarily like being a, because the hydrogen only have 1 valence electron. It can just go anywhere, right? But we just need to break 1, I think. Like we don't have to break all of them.
So you're saying that if it's broken from the N and it connects to the H, then it can't connect
But like,
also to N because it has to.
I'm not really sure, but like it's just being broken twice apparently. But it's just being broken once from each side to get the 95. Okay, I'll ask the professor about this question. I'm a bit confused myself. But solution is just saying like spin. Okay, I'll confirm with the like professor over the weekend. Like get back to you on this question. But I think it's only being broken once here, right? Then it's connecting with this one, and then only being broken once here to be connected with this one, because this question is just being like shown how many 2H2, right? So we just have like two bonds that's been like formed originally. So if I were to do like 3, 6, it would be 7, 7, 2, minus 8, 44, 7, 7, 2, minus 64 would be 92. Okay. Yeah, no. Okay, I'll get back to you on this question. I don't know how we can do this, but yeah, sorry about that. But it's just like being the bonds being broken and bond being formed for these type questions. Um, sorry. Let me see. Yeah, okay. Let's just move on from now, right? I'll make a video about this and post it again. But in my solution, I have it written like this. So wait, let me see. Cross cross.
I have a question though. The 772 minus 864, I get negative 92.
Yeah, true. I get the same negative 92. Maybe I did something wrong. Maybe like we can hold on. Let me redo this question. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So connect 3 bonds. Okay. So we have 4. Okay, maybe we could connect like single bond. Maybe that's why. All right, so it's going from single bond, and we have N2 plus 2H. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One, two, three, four, 5. 1, 2, 3, 4, 5. 1, 2, 3. It's connecting with this. It's connecting with this. Plus 2H2. So all right. So bond formed. Bond broken. So we have this bond. Sorry, you guys. Give me like 2 minutes and I'll try to clear this, okay? Okay, so we have. Hello? Are you guys still here with me? I'm so sorry. I know it's kind of boring. Give me 1 minute, all right?
Yeah, we're still here.
942. We have H to H. We have 432. 432. Okay. Um. hmm, 386. 386. 386. 386. I don't get it right. Okay, hold on. So we have triple bond funded. 42. Okay, it's one being broken. 36. Okay, wait. Okay. 4 minus. I don't know why. Okay, I can't get it right even if I do the single bond. How's it 95? Okay, I'll ask the professor about this question. Sorry about that. I don't know. I don't know why I can't get it right. Okay, all right. Let's move on. I'll come back to this later, all right? My solution here is incorrect, it seems as well. This is not being changed. Maybe if I form, okay, wait. One, two, three, four. 1, 2, 3, 4. So we have single bond here, plus okay. So maybe we don't have to make it a double bond. So we have 4, 2 bonds being broken. So we just have that. Still doesn't make sense. Huh. Okay, I don't know. This question still doesn't make sense. It's crazy. Hold on, let's do a different question. Let's see. Maybe that has his formula incorrectly. That's problem. Chapter 9, I think. Chapter 8 or 9. No, it was chapter. Okay, it was this question. Let me try to get. It was this one, right? It was 95. It wasn't 95. Okay, wait. Let's see.
I think your answer was negative 95.
Negative 95? I don't think so. Wait. Okay. That sucks. Where is it? Okay, I'll just ask the professor about this question. I'm not sure, like, why is it not? If I can figure out the right answer. Okay, yeah. So you said it was negative 95? See. Okay, it was negative 95. Okay, I don't know. I don't know. We'll figure it out again. Figure it out later. We're wasting quite a long time. Anyways, I'll move on from this. I'll get back. I'll make a video about this later, and I'll see. I'll confirm with the professor as well. Sorry about that. I know it took so long. I thought I got it, but anyways, this is from chapter 7. And Arban was supposed to cover this chapter, but he got sick or something. So let me just cover this real quick, and we'll end it. We'll end it after we have done these problems. All right. Sorry to disappoint you about this problem. I'll get back to you as soon as possible for this one, but I don't know why. Okay, whatever.
Never mind.
What's up?
Never mind. Never mind.
Did you figure it out? Like, why was it negative 95?
I mean, I searched it up, but I also don't get it. But I kind of get it. But I don't know.
Could you explain maybe? Like, maybe you can just figure it out now because I don't want to remake a video, bro. That's too much. So why was it negative 95?
So like what it told me was like there was one bond broken between the nitrogen and then 4 bonds broken between the nitrogen and hydrogen. So I don't know how that looks like when we draw it up, but
Yeah, that's what we have too, right? So
and then the bonds formed, there was like the triple bond formed between the nitrogens and then the 2 bonds formed between the hydrogens. So that's why.
Okay, say it again. So bond broken was what?
So bonds broken was the one between the nitrogen, so that's like 167. Wait, was it? Wait, what?
So it's from nitrogen to nitrogen.
Yeah, nitrogen and nitrogen. Yeah, 167.
Okay, when nitrogen to nitrogen, 167. Okay, but like, what else was it broken? Oh,
And then
okay.
the four
Oh.
between the nitrogen and hydrogen.
Oh, so is it making single bond instead of triple bond?
The bond formed. We're gonna have the triple bond between the nitrogens. So that's like on the product side. On
Okay.
the side.
Okay, so no, in bond broken, right? Initially in the product, it's just making a single bond instead of like a triple bond.
I think so.
Yeah, that makes sense too. All right, cool. So what about like bond form? So how many bonds form to be had?
The bond formed would be the triple bond between the nitrogen, so that would be 942.
942, 420, 432, and 432, right? So total is 106, 1806.
1806? Wait,
What?
942 plus 864.
Oh, okay. All right. So is that the y? So we have end to end. We have
And then you
167. All right. Thank God. Okay.
when I subtract it, you get 95 minus 95.
106. Oh, okay. Yeah, you get minus 95. Oh, okay. All right. Okay, I understand. Okay, now I understand. All right, cool. This is the answer key. Okay. All right, let's just redo this problem, all right? We spent like 20 minutes. I'm so sorry, guys. I know I kept you long, but let's just redo this question. Sorry, get me? Let's
Yeah,
get started, all right? Let's just redo.
Yes, please do it.
Okay, so it's not making triple bond, as I said this above. It's making a single bond. Okay, that's why. So we have in the reactant, right? Oh, okay. So we have N, N, and we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So instead of making a triple bond as I said, it's just making a single bond. So it's connecting like this first. It's connecting like this first, right? So that's why we only have one bond first. So the reactant is going to be like okay, the reactant is going to be like N to H, N to H, connecting N to H, N to H, 1, 2, 3. So it's gonna be like this. It's gonna be like this. So that's 5. That's 5. So this is the product, right? And what else we had? Yeah, that's it. So and it's forming N2 to H. So N2, if it's just connecting like that, it can be formed like this. and we'll have 2 valence electron here, and plus. So it's being like this. So do you guys understand till here?
I understand it, but like, why does it start off as a single and then goes to a triple?
Why did it go? Okay, because we are just having we're just connecting n to n, right? So if you were to say like, okay, how would you connect n to n, right? Even though we can connect it with a single bond, actually you can't connect it. We can connect it with a double bond, right? Wait, how many is it? 1, 2, 3, 4, 5. So 1, 2. Yeah, we can connect it with single bond, right? We can also connect it with the triple bond. You can't connect it with the double, like.
Well, I think okay. So N2 has to have 3 because it can't like have less, but N2 and H4 can have less because it has the H's.
Yeah. That's why I messed up.
Okay,
I was
okay.
drawing.
Okay.
Okay, yeah, because I was drawing the earlier, like I figured that's where I messed up. I tried to connect 1, 2, 3, 4, 5. Yeah, 1, 2, 3. Yeah, I don't know why. So it can only have a single. We don't have to connect it with here. We can just have a lone pair. That's where I messed up earlier. That's why the answer was kind of getting flunked. Anyways, um, so okay, are we like caught up to speed till here? It's a product reactant, right? So we can have 3 bonds here when it's just end to end. We don't have to connect it with H, if that makes sense, right? Anyways, so bonded pair, we have, all right. How about this, guys? I'll just make a video on this. I understand it now, right? I think it will be like, it will take too long to explain everything. I'll just make a YouTube video on this. Does that sound good?
Yeah.
It makes sense now.
Yeah, but like, only thing I messed up earlier was making a triple bond, like a triple bond in the product, and not counting for the single bond. That's pretty much it. So instead of having like single bond here in product, I just made a triple bond, and that's wrong.
Reactants?
Yeah, in the reactant, you're not supposed to do that because there's an H. You know what I mean? So if there was
Yeah.
just like a end to end, then you can make a triple bond. But since there's like a H and everything else, the max you can go is like a double bond. But we can also connect with like, or you will only make like a double bond if there's only a single lone pair here. So let's say there wasn't like any like there was a -1 valence electron, right? But this was just lonely here. Then you would make a double bond. I didn't consider that like we have to take 3. So we already have like bond like lone pairs here. So we don't have to, it's not necessary to make a triple bond, if that makes sense. But in the reaction we had to make a triple bond because it's only bonding with end to end.
That makes sense.
Yeah, cool. That's
Wait,
why
so
yeah.
so before with the 3 bonds and the extra H's, that's wrong because it's 1 extra bond that you can't have.
Yeah. So in the
Okay,
product you
okay.
can't have 3 bonds because we have to consider the lone pairs here. That's the only thing I made a mistake on.
Okay, that makes sense.
So this is the solution sheet, if that makes sense. Broken bond formed. Okay. Yeah, I'll draw a nicer one and I'll put it up in the solution before I put it up. But does anybody like I got stumped a little bit, but at least do we need to know the concept behind it? I'll do like 4 problems more related to this question, so we don't like we have an idea of it. All right. Okay, well, let's move on to the next question. It's like hellish to draw here, so um. All right. So Arban's gonna make a comprehensive video on chapter 7, just like all the questions from chapter 7. I'll just cover like 3 of them here, right? And we can call it a day, right? So this question is asking about like the wavelength radiation and with the frequency. The the formula for wavelength is this, right? this represents a wavelength, right? Which is equal to speed of light divided by the frequency, right? And the speed of light is constant with 3.0 times 10 to the 8th. And the frequency is given here. So only like thing you have to do is conversion. So we have 3.00 times 10 to the 8th, right? And we have the frequency of 8.2 times 10 to the 9. So the answer will be 0.36, but we have to convert it to the PM. PM just means it's 16, right? So we have to go, wait, what?
Pico is -12.
Yeah. So the answer will be here. Okay, I want you guys to do this question. It's the same, I'll just get it started, right? It's the same formula type. Do I have a solution for this? Okay, I don't. All right, so C divided by V, C is 3.00 times 10 to the -8. What's a -8? Yeah, this is positive. Divided by V, which is 7.317, 10 to the 12. So what will be the answer here? Hello? Is anyone still here?
Yeah, I'm just doing the calculation right now.
One, two, okay. So we have one, two, three, four, five. That's 4.
Is it A?
Yeah. This is a very simple question. It's not like really too complicated. Anyways. All right. Okay. So let's do question number 2. What is the wavelength of line in Pansol series of hydrogen spectrum that transition occurs from n initial of 8 to f final of 3? Remember the Reisenberg constant is 1.09 times 10 to the -2. All right, so we have to use a Reisenberg equation for this one. And the equation states that we have one wavelength is equal to one, wait, is it R? Hold on. So yeah, so R of H times NFN2 minus NFN1 initial. All right, so I'm just gonna say the constant here, and you guys can like kind of figure it out. So RH is given, so we have 1.097 times 10 to the -2, and we have n final, which is 3, and n initial, which is 1. Is it 1? It's 8. So insert home slide. So just taking this, okay, when you plug in these formula, what you guys get in the calculator? I'm just gonna write it in my calculator. So RH is 1.097 times that by 10 to the -2. And we have bracket that by 1 and squared. So final it's 8 squared minus minus 3 squared. So I mean it's equal to negative 1.047. Wait, did I do it wrong? Wait, I did it.
Yeah, negative.
Yeah, it's not negative. Sorry, I put the. So it's gonna be 3. It's gonna be 8. So it's gonna be positive. Sorry. Do you guys get this? Like here?
Yeah.
Okay. But we are solving for this constant, right? So we have to move this variable here, move this variable here, and divide by 1, right? So do you guys understand this? So we have,
Yeah.
So constant is equal to 1 divided by 1.04, whatever, blah, 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 right? And what is the final answer?
I got 955.
Yeah. So, I mean, in my solution, I also had 954.7, right? Same thing. This is the same question with different constant. So if you guys want to do it with me quickly, we can. So we have RH. This is 1.0. Okay, tell me what the answer is for this question. Have you guys already done this before? Like, are you guys just starting to study one?
Gone over
I'm
it.
starting.
Okay. And then the formula was final, right? Yeah, final first. So it'll be So what is the answer for this one? What'd you guys get?
97.
All right, cool. Did everybody get the same answer, or do we have to like go over it again just to make sure we all on the same page?
I got it.
Cool. All right. All right. So okay, so this problem number 3 is the same as problem number 1 and 2. Like wait, problem number 1 and wait, what was problem number 1? Problem number 1 was different. Okay, it's the same as problem number 2. The only difference is that it's asking for the longest form, right? So where to go? So this is asking for the longest form. So the final is this, right? But this will be initial. And the longest, we have final initial of 4, and this will turn into initial. That's pretty much it. That's not what I mean. Hold on.
The
So
initial would be 3, right?
yeah. So initial will be 3. I mean, the final will still be 3, but initial will be 4. That's pretty much it. You're just adding 1, and this is your new constant. If that makes sense. So it's the same formula. You do the same thing, but that's where you get the form because it's asking for the longest weight. You just add 1 to it. So initial will be like 4. Does that make sense?
Confused why you got 4.
It's just what it is. It's just one of the longest wavelength, right? What is the longest wavelength? So the longest wavelength has to be always the one that's adding to it, right? So it can be lower than 2, right? It can be lower than 3 because it's long. It has to be greater than 3, but we don't know how much it's a greater. So we go with the next integer, which is 4.
Okay, that makes sense.
So you
Right.
say like longest wavelength is like the smallest energy transition.
Yeah, basically, yeah. Yeah, that's pretty much it. So he's just asking for like which one's the longest. You just add one to it, and you just do the same thing as problem number 2. All right. Problem number 4. Okay, wait. Do I have a solution here? Okay, well, what is a wavelength of photons having energy from K? Okay, so we have when it says for photons, right? We have to convert it to what do we need to convert it to?
Lambda or wavelength rather.
Yeah, right. So this is asking for wavelength, right? But we have energy of this. So first we have to convert this to photons, right? Okay. Insert. Okay. So this will be 0. Okay. Converting to kilojoules, kilomoles to from. Okay, this will be to joules per photon. So the way you do this is by taking whatever the initial was given. So we have 0.000157, and we divide that by Avogadro's number. So 6.022 times 10 to the third, 23rd. And this will be equal to 2.61 times. And 2, what will be the answer? God damn, I have a solution incorrect, I think. Okay. Yep. So it'll be, would it be 27 or 28? Hello? Okay. So we use after that we use the wavelength formula for Avogadro's number. We put Avogadro's number here times 10 to the 23. Multiply that by the light constant, which is 3.00 times 10 to the 8, and we divide that by what was it? This new constant. This one, 2.61.
Are you supposed to put Planck's constant as the top left numerator? Not Avogadro's number.
Okay.
So it would be
Oh, yeah, you're
6.62
right.
times 10 to the negative 34.
Yeah. My bad. Jesus, it's been a long day.
I hear you, man. You're good.
Yeah, just change the topic. Planck constant. Sorry. 2, 6 times 10 to the negative 34. Okay, we'll change it here.
No, you had it right the first time. You do divide it by Avogadro's number, but so in the top where it says lambda equals, yeah, there we go.
Oh, yeah, my bad. Okay.
And then I think we have to like make the units match kilojoules. But I mean, we can do that after.
Okay, so hold on. This is Avogadro's number here. Sibonga national. Good phone engine. 23. Action away. So this would be Planck's constant here. Okay, so I mean this will be some close answer to 8. So there's be like something like this, right?
Yeah, because you would get everything to agree to meters or kilojoules rather, and then convert it to meters. Well, the outcome, since you made everything agree, the final would be meters, and then you just multiply that by -9, or not 10 to the -9th or whatever. It would just be 10 to the power of -9, and then that would give you the answer for nanometers.
How did I confuse it? Okay, my bad. My bad for confusing the Avogadro's number with Planck constant. Sorry about that. So it'll be converted to nanometers. Yeah. All right. Cool. That's all I have for today. This chapter 7 is pretty. I mean, just conversion factors and whatnot. But do you guys have any other questions regarding to like any of the? Okay, I'm gonna try to cover this question while I'm still here. Okay, I'm gonna start to redo this, but you guys are free to leave. I'm probably gonna end it.
I have a question.
What's
Did
up?
you, I'm not sure if I missed it. Did you go over chapter 9? Because there was a specific problem that I didn't really get.
This one?
It was like a problem about like lattice energy. I don't know if you went over that.
Oh, the highest lattice energy and whatnot. Isn't it just like looking at the trend and whatnot?
Hmm.
Okay, which one is it? Problem
Um.
number 1?
Wait, is it on this slide?
No, I don't think so.
Oh.
Because I just picked like one question from it because it's just the I'll be honest with the other ALAs. Arvin was also supposed to work on this together, but he had like a family emergency, so whatever I didn't cover, whatever the question that I didn't cover, he's probably gonna cover it. So are you talking about this one?
Yeah, it was problem number 1, but
Yeah,
it's okay.
yeah, he's probably gonna cover this, but let me try to go over like this question. Like I hate like not being able to finish it, but I'm okay. I'm just gonna let him know what questions he needs to be covering and whatnot. All right. My mom's kind of yelling at me. I'm not gonna lie, but uh, let's just do this question. Should we revise this question? What do you guys think? Give me your opinion. Hello?
I think it's fine. I just think it's like
Yeah,
it's just like confusing to know whether it's triple bonded or single or double bound, because it's not necessarily, I mean, it is listed, but it's not like a,
like it's not listed, right? Like we have to
yeah,
like
I mean, like knowing the Lewis structure, like having to make that n bound covalently with 3 of the valence electrons is like a little bit confusing. But like
if you
if
just
you observe the trends,
yeah. All right. I think I'm gonna call it quit like end here, right? Just stop recording for now. But I will make another video regarding this problem specifically because I did mess up. Sorry for that. And I'll Arbine will also be covering like chapter 7 and the like chapter 9, some questions from chapter 9. Okay, I'm gonna leave some work for him as well. Does that sound cool?
yeah, thank you so much for your time, man. I really
Thank you so
appreciate
much.
it.
Okay, I just want to let like you guys gonna be honest. I'm gonna stop the recording.